Okay guys, so this video is about compound inequalities. You're going to be taking these notes on the very front page of your green packet. You'll see even before we get into page 1, there's a blank sheet of paper. Let's take the notes on that page. So compound inequalities, there are two types. There's the AND compound inequalities, and there are the OR compound inequalities. And just like the way it sounds, and is when two things need to be true. If I were to say that you need to do your homework and wash the dishes, that's having to do both. If I said or, you need to do your homework or wash the dishes, it could be one or the other. You have a choice. So and compound inequalities are written like this. -3 is less than x, and x is less than 3. So -3 has to be smaller than x, and x also has to be smaller than 3. So x, if we make it on a number line, here's -3, -2, -1, 0, 1, 2, 3. X is any number that is bigger than -3 and smaller than +3. So we put open circles, and the numbers that work are between -3 and +3. So for example, -2, that number works because it's bigger than -3, but also still smaller than +3. A number over here, like -4, would not work because -4 is not bigger than -3. Or inequalities are when one or the other has to be true. So maybe x has to be less than -3 or it has to be greater than 3. So the graph of this would look like, here's -3, -2, -1, 0, 1, 2, 3. Smaller than -3 is on this side. Bigger than +3 is on this side. So ORs are really just two separate inequalities on one graph. I always like to say they look like two oars in a boat. So row, row, row your boat with the oars. Two oars in the boat. So here are some example problems. With AND inequalities, when we have something like -2 is less than or equal to 2x minus 4 is less than or equal to 6. With something like this, I really want to look at this as having three distinct parts of the inequality. So I'm trying to solve for x here. So to solve for x, I would need to add 4 to both sides of the inequality. So I have to keep it balanced by adding it to really all three parts. So I would get 2 is less than or equal to 2x, which is less than or equal to 10. And then I need to divide by 2 to get x by itself. So I divide both sides of the inequality, and I get 1 is less than or equal to x is less than or equal to 5. If I made a graph of this, you only need to write the two main numbers that we're looking at. So we're looking at 1 and we're looking at 5. We're going to put closed circles on both and say since x has to be bigger than 1 and smaller than 5, the only numbers that work are here. 1, 2, 3, 4, 5. Those numbers are the only numbers that would work for x. Okay, so another example. Let's say we have -6 is less than or equal to -3 times x plus 4 is less than 9. I want to go ahead and distribute my -3. So I'd get -6 is less than or equal to -3x minus 12, less than 9. And again, I'm solving for x, so I need to get rid of the plus 12 first. So I add it to the 9 and to the -6. That gives me 6 is less than or equal to -3x is less than 21. I divide by -3 all three things to get negative 2. Since I'm dividing by a negative, I have to flip the inequality symbol. And I get that x has to be between negative 2 and negative 7. Just careful how you graph this, because negative 7 should be on the left-hand side. That's going to get an open circle, and negative 2 is going to get a closed circle. ORs are really nice because when you solve them, you just solve each inequality separately. So here, I would subtract 7 from both sides. 2y is greater than 6, divide by 2. My first option is that y could be greater than 3. Or, if I solve this next one, y is going to be less than or equal to negative 4. So my two options are y is greater than 3 or y is less than or equal to negative 4. So on my number line, here's negative 4, here's 3. Closed circle, pointing below negative 4 for the first inequality. Open circle, pointing above 3 for the second inequality. So ORs are really the easiest because they allow you to solve each inequality separately.